All right, welcome back. This is the discussion section for 10.6, which is on the Cramer's rule. So there was a couple of questions asked. I'll just dive into those. Let's start with number 4. It says, find the determinant of the matrix if it exists. If it doesn't, enter DME. And we have 2, 1, 3. 0, 2, 1, 3, 5, negative 1. So we're looking for the determinant of this matrix. Typically, whenever I see a 0, I want to exploit that. So I'm going to expand this matrix along this column, 2, 0, 3. Because if you have a 0, you can exploit it. It eliminates a huge calculation. Well, huge, whatever. It eliminates a calculation, right? So I'm going to start here with 2 multiplied by the determinant of the 4 by 4 that is created when the row and the column of that 2 are eliminated. So 2, 1, 5, negative 1 goes here. Okay. The matrix has a plus minus array, so when I get to the 0, it's minus that 0, but it doesn't matter because it's 0 times something. But just for complete sake, we'll write this out. If I take out the row and the column, I'm left with 1, 3, 5, negative 1. And then I'm back to a plus 3 times the 2 by 2 that's created when the row and the column of that entry are removed. So 1, 3, 2, 1. Okay. Now again, the nice thing is I don't care about this middle thing because it's 0 times who cares? It's 0, right? This 2 gets multiplied by the determinant of the 2 by 2, which always goes in that little ribbon crisscross upside down looking thing, but 2 times negative 1 is negative 2, minus 5 times 1, so negative 2 minus 5. So plus 3 times 1 minus 6. Right. Or 2 times negative 7 plus 3 times negative 5. Okay. Or negative 14 minus 15, so I get negative 29. Good. All right, and then the other one asked was number 10. Which says, use Cramer's rule to solve the system of equations. So Cramer's rule is all about these determinants. I've got a system 3x plus y minus 2z equals 2. 2x minus 2y plus 3z equals negative 10, and x plus 4z equals negative 9. Okay. So the first thing I want to do in order to find Cramer's rule is to find the determinant of the variable matrix. Right? So the determinant, I'm going to call it D, is simply the determinant of 3, 1, negative 2, 2, negative 2, 3, 1, 0, there's a 0y here, so just 0, and then 4. Right? That's, whatever the determinant is here, that's D. So I'm going to exploit the 0 down there. I'm going to expand on this. The 3 is in the positive. It's always positive, negative, positive. So I'm starting with a positive with this 1. So So that's 1 multiplied by, take that out and that out, 1, -2, -2, 3. Minus 0 times who cares? I don't, I'm not gonna write it. Plus, again, 4 multiplied by 3, 1, 2, -2. Okay. So this is 1 multiplied by 3 minus is minus, so minus 4 plus 4 times -6 minus 2. So -1 plus 4 times -8. So that's -32 minus 1 more is -33. Okay. Good. Now, that's the determinant of the matrix of the variables, right? And I'm going to erase a lot of this. I'm going to write up here my capital D for determinant is -33. Hopefully it's right, it looks right. It's a yuck number, but here we go. Let's get into the next one. dx, the determinant of the x, is the determinant of that same matrix except for my x column. So I'm going to write the rest of it. I've got a 1 in the y, the -2, another -2, a 3, a 0, and a 4. But instead of that first column, the 3, 2, and the 1 from the x, I'm going to replace it with the variable, the answers, the solutions, the constant numbers on the right hand side. So I'm going to write this as 2, -10, and -9 in place of my x variable coefficients, and I'll find the determinant of this matrix. Once again, I'm going to exploit that 0. I'm going to exploit that 0 as long as I can. I lose the ability to do that when I do my dy. We'll see that in a minute. But I have it still, so I'm going to use it. So this is then equal to -9 is in a positive spot, which means you just don't change its sign. So it's a positive -9. Multiplied by, if I take that out, I get 1, -2, -2, 3. Minus 0 times who cares, and then plus 4 times 2, 1, 10, -2. So that is -9 multiplied by 3, minus, 3 minuses, goes back to minus, so minus 2 times 2 is 4. Plus 4 times 2 times -2 is -4. Minus 10, so plus 10. So this is -9 multiplied by -1 plus 4 multiplied by 6. Hopefully it's a multiple of 33 in the end, otherwise I might be revisiting my determinant. But here we've got positive 9 plus 24, which is indeed 33. That's a good sign. Okay. So that's my dx. And that was 33. Okay. For my dy, the next one I want to do, I'm going to, instead of the x row, or column, excuse me, I'm going to throw those guys back in there. But to do dy, I'm now going to replace the y column with that 2, -10, and -9. And go through the same process. I don't have any zeros in here, so there's nothing worth moving over to exploit, so pick a row, pick a column, it doesn't really matter, right? So here I get 3 multiplied by, what's left is the negative 10, 3, negative 9, 4. Minus, the 2's in a minus spot, so minus 2 multiplied by, get rid of the row and the column, I'm left with 2, 3, 1, 4. And then back to a plus spot, but this is minus, so it doesn't change it, it's minus 2 then, right, times 2, negative 10, 1, negative 9. Okay. So then this becomes 3 multiplied by negative 10, negative 40, minus, but then it's minus 9 times 3 is negative 27, so minus minus is plus 27. Okay. Minus 2 multiplied by 8, minus 3, and then minus 2 multiplied by negative 18 plus 10. Alright, so this is then 3 multiplied by negative 13, minus 2 multiplied by 5, minus 2 multiplied by negative 8. Okay. So that is negative 39, minus 10, and then plus 16. And that's negative 33. Alright, so I'm going to not do Z. Z is just the same kind of process. What I'll do here though is skip to how you find the answer. Your x is the determinant of the x, that dx, where we replace the x column with the solutions, divided by d. And y is the dy divided by d, and similarly, I didn't do it, but z, it would be dz divided by d. But x then is 33 over negative 33, so that is negative 1. Y is dy, which was negative 33, divided by d, which was also negative 33, so that's positive 1. And then whatever z ends up being. I'll let you guys go through 12, z, I don't know where 12 came from, but give it a shot, see if you can figure that out. Thanks, hopefully this was helpful, and I'll see you for the next one.